guys, and welcome back to Visual Learners. We have already wrapped up the discussion about YOLO, the YOLO model, but according to popular demand, I wanted to make the last video for the YOLO tutorial series. The YOLO V8 model was released in January. During that time, I already started the PyTorch series, so I didn't have enough time to make a video about YOLO V8. So I wanted to make the last video for the YOLO tutorial series, which is the YOLO V8 model. YOLO V8 model was released by the same company that released YOLO V5, which is known as Ultralytics. So first, let's see the introduction to the YOLO V8 model. In this video, we'll be focusing on YOLO V8, which is the latest version of the YOLO system developed by Ultralytics. YOLO V8 is the latest iteration of Ultralytics' popular YOLO model. It is designed for effective and accurate object detection and image segmentation. YOLO V8 was released in the 10th of January 2023 and was launched claiming advancements in structure and architectural changes with better results. So there are a lot of new things that are released together with the YOLO V8 model. So according to the website on Ultralytics, they categorized all of the things that you can do with the YOLO V8 model. The first is labeling and source of the dataset. And you could label and export your custom datasets directly to YOLO V8 for training with the website RoboFlow. This is nothing new, but the new ones are starting from the training procedure. Here you can use a notebook paper space, and you can use the loggers ClearML and Comet. This can be found from the GitHub page of Ultralytics YOLO V8 model. ClearML is a new logger which automatically track, visualize, and even remotely train YOLO V8 using the open source ClearML. And Comet is a free, forever platform, and it lets you save YOLO V8 models, resume training, and interactively visualize and debug predictions. Finally, we have Neural Magic, which runs YOLO V8 inference up to 6 times faster with Neural Magic Deep Sparse. So if you want to deploy the YOLO V8 model, you can use a Neural Magic, and the exports can happen for TensorFlow, PyTorch, and other AI frameworks. Before we delve into the YOLO V8 model, let's see the timeline and the progress from YOLO V1 up to YOLO V8, so that we can understand the pattern and how it got from the original state to the current version. YOLO version 6 and 7 were released to the public over a period of 1 to 2 months by different authors. So we had YOLO V1, which was released in 2015. Then we have YOLO V2, which is also known as YOLO V9000, which was released in 2016 after 1 year. And YOLO V3 was released after 2 years in 2018. And all of these YOLO models were written by the same author. And finally, in 2020, we had a lot of YOLO models that were released from different companies and authors. YOLO V4 was not written by the original author. It was written by Alexei Bukovsky. YOLO V5 was released by Ultralytics, which is the same company that released YOLO V8, and PP-YOLO was released by Baidu. In 2021, PP-YOLO V2, which was the second version of PP-YOLO, which was released by Baidu, was again released in 2021, and another model known as YOLO-S. In 2022, we have the new versions YOLO V6 and YOLO V7. YOLO v7 was released by the same author as YOLO v4, and YOLO v6 was released one by Baidu, and there were multiple versions for YOLO v6 which were released by different entities. And finally, we arrive at the new model YOLO v8, which was released in 2023. So YOLO v6, 7, and 8, all of them were implemented using PyTorch. And even its predecessor, YOLO v5, which was released by the same company, was a PyTorch-based model. And it was released by Ultralytics. So I've mentioned the name Ultralytics a couple times. So let's try to understand what the company is all about. Ultralytics is a company started with the goal of making model development accessible, efficient to train, and easy to deploy. It's been surfing the AI landscape since 2014, working with the US intelligence community and Department of Defense initiatives in the fields of particle physics, data science, and artificial intelligence. So the team is made up of a lot of developers, and the founder and CEO of Ultralytics is known as Glenn Joker. And Glenn founded Ultralytics in 2014 to lead the United States National Geospatial Intelligence Agency, also known as NGA, anti-neutrino analysis efforts, culminating in the mini-time cube experiment and the world's first ever global anti-neutrino map published in Nature journal. Second, we have Sergio Sanchez, who is a mobile app developer. He started his career as an Android developer, primarily focused on front-end with back-end support, designing the UI and UX of mobile apps, following the material design guidelines for Android and Apple's human interface guidelines for iOS. Finally, we have Kellen Michael, who is the lead web developer. He was a coder since he was gifted his first computer at 13, and Kellen enjoys solving challenges in the most efficient way possible. The previous version of YOLO v8, which is YOLO v5, when it was released, you can only download the repo from GitHub, and you need to set up the environments by yourself in order to train the model. But in YOLO v8, they released what's known as Ultralytics Hub, which is they also have a website and an app, which can be downloaded from the App Store or Google Play. It helps you to experience seamless AI with the platform, and it's an all-in-one solution for data visualization of using YOLO v5 and YOLO v8 model training and deployment without any coding. So anyone can just use the app to train using a custom dataset without any need to code. You can also transform images into actionable insights and bring your AI visions to life with ease of using cutting-edge platform and user-friendly Ultralytics app. Next, I'm going to show you a short video about Ultralytics so that you are familiar about the company, and we will continue discussing the YOLO v8 model.
Ultralytics really has a singular mission. We're looking to make AI as easy as possible for the largest number of people that we can. My name is Glenn, and I'm the founder at Ultralytics. I worked on particle physics applications for a few years before we started getting into artificial intelligence. When I was working with the University of Hawaii on some government programs for particle physics, we had some pretty difficult things we were trying to solve. And artificial intelligence solutions were one of the things that I first started using to solve some of those really hard problems. And the more I looked into it, the more I realized that it had great potential, not just for physics, but in other aspects of society, and really to change our whole world.
YOLO is an object detection algorithm that you can feed images into, and it'll actually draw bounding boxes around the items that it detects inside of the image.
I think as more people discover the technology and work to integrate it into their own products, I think the limits are really boundless for what you can accomplish with this and the different areas of society that it can impact. So I'd say the number one thing that we offer is simplicity and usability. So there's a lot of AI architectures out there, and the way that we differentiate ourselves is that when you use YOLO V5, it just works, like Steve Jobs would say. We try to make it so that you get a good result out the door the first time, and you don't have to iterate and experiment and really spend a lot of time getting a good result. There's a deep plastic company which is actually working to clean up the world's oceans using YOLO V5 and a submersible which collects plastic bags from the world's oceans.
Once you can detect objects, you can do anything with that, right? So if you want to take it back to the recent situation with COVID, right? You can easily train a model to detect whether someone's wearing a mask, not wearing a mask, or wearing a mask incorrectly, which I actually saw someone online manage to implement that.
One of the ideas we had was to create the world's first male STD scanner, and we realized that we could employ all this models that we had created to do something good for the world. And we realized then that this is a difficult task. You've got to get all the images and train this model, dump it onto a phone and stuff. And we realized, hey, we want this to be easy for everyone. Since we're facing this challenge right now, why don't we just build the tool to make everyone be able to do this themselves?
So one of the main problems these days is to use an AI solution. If you have a project or a product, you really need to be an AI specialist. And a lot of the time, the people that are creating products don't have a lot of AI expertise. And so we're aiming to bridge this gap that exists right now by creating a product that all developers can use, and even students, so even high school students, could upload their data, train a model, and deploy it wherever they need to. And so I think this will expand the addressable market for people and enable access to AI solutions where it didn't exist in the past before.
The thing that I enjoy most about working on Ultralytics is, the people that we work with. As we started out, as a fairly small team, we're starting to grow, but we all know each other pretty well. I think it's exciting because a lot of us are just bringing new, fresh ideas. A lot of the team is young and they have a lot to offer, and they just, have that go-getter attitude. Really just want to achieve something.
Everyone on the team is really, really passionate about what we do and really interested in the topic. For that reason, it's such a treat to be on a team that is, once again, so motivated.
I think the best part about having a small organization is that every individual in the organization has a great impact on the products and the direction that we take the company. We want to empower researchers, empower students to develop their own AI technologies and their own architectures. And we really feel that our open source contributions to society, like YOLO V5, and now our web deployment solutions like the Hub, will really be able to help people that may have been interested in the field but may have seen it as too complicated, really take that first step and start their journey towards AI development.
Okay, next let's discuss about why should we use YOLO V8. A few of the main reasons you should consider using YOLO V8 in your next computer vision project are: it has better accuracy than previous YOLO models, and the latest YOLO V8 implementation comes with a lot of new features. We especially like the user-friendly CLI and GitHub repo. It supports object detection, instance segmentation, and image classification. The community around YOLO is incredible. Just search for any edition of the YOLO model and you'll find hundreds of tutorials, videos, and articles. Furthermore, you can always find the help you need in communities such as MLOps community, DCAI, and others. And training of the YOLO V8 model will be probably faster than the other two-stage object detection models like Mascar CNN. One reason not to use YOLO V8: at the current time, YOLO V8 does not support models trained in 1280 pixels resolution. Thus, if you're looking to run inference at higher resolution, it is not recommended to use YOLO V8. You can only use for resolutions that are below 1280. So what are some of the YOLO V8 models? In YOLO V8, there are 5 different models available for each category of detection, segmentation, and classification. So each of them have these varieties of models. And YOLO V8 Nano is the smallest and fastest model, while YOLO V8 Extra Large, YOLO V8X is the slowest, yes, yet most accurate model among them. So Nano is the smallest version, and YOLO V8X is the largest model. Next, let's talk about the network architecture and design. The actual published paper has not been released yet by the creators of YOLO V8, promised that it will come out soon to avoid the drama around YOLO V5, because YOLO V5 still doesn't have an officially published paper, so they promised that they will release a paper for YOLO V8. Thus, they don't have a good overview of the methodologies used during creation, nor do I have access to the population studies conducted by the team. But I'll just release an updated version as soon as the paper is published. Luckily, we can find plenty of information online and in the GitHub repository to discuss in this video. So next, let's talk about the layout of YOLO V8. We won't go too much into the detail about the YOLO V8 architecture, but we will cover some of the major differences from previous iterations. As you can remember from the structure of YOLO, we can see that it has a backbone, head, and neck. And the following layout is actually provided by the GitHub repo called Range King. So if you want to see the detailed architecture of the model, you can go to this GitHub repo and download the image, and you can try to understand all of the convolutional blocks used in this model. So here you can see that this is the backbone of the model, and the conv layers detailed description is here. These are the conv blocks, and the C2F blocks are these ones. And on the neck region, we can have some bottleneck layers, and we have some SPP block. And for YOLO V8, they use a block known as SPPF block. Then on the head, you have a couple of convolutional and concatenation layers, and we have the detection regions. And you can see the detail of the detection layers here, and we are actually detecting the objects on different scales. That's why we have 3 detection layers. And for each layer, we're predicting the bounding box and the class, and we're calculating the loss. And the loss used is the CIOU, and for the classification, it's binary cross entropy. YOLO V8 is different from YOLO V5 and the previous YOLO models because it's anchor-free. It's similar to that of the YOLO R model. Anchor-free detection is when an object detection model directly predicts the center of an object instead of the offset from a known anchor box. So previously we have seen that in order to make a prediction box, we have to rely on an anchor box, which is going to be the base, the box that we use originally in order to predict a new box from it by adjusting the coordinates using the offsets. And anchor boxes are predefined set of boxes with specific heights and widths used to detect object classes with a desired scale and aspect ratio. They are chosen based on the size of the objects in the training dataset and are tiled across the image during detection. The advantage of anchor-free detection is that it is more flexible and efficient, and it does not require the manual specification of anchor boxes, which can be difficult to choose and can lead to suboptimal results in previous YOLO models such as V1 and V2. So being anchor free actually saves some computational power, so that's why it's more preferable. So finally, let's see how to implement the YOLOv8 model. The model comes bundled with the following pre-trained models that can be utilized off the shelf in your computer vision projects to achieve better model performance. It can be used for instance segmentation, models trained on the COCO segmentation dataset with an image resolution of 640. It can also be used for image classification tasks for models pre-trained on the ImageNet dataset with an image resolution of 224. And it can also be used for object detection for models trained on the COCO detection dataset with image resolution of 640. So for the COCO dataset, we can do both object detection and segmentation, and we can do the classification task for the ImageNet dataset. That's how it's pre-trained, and we can use our custom dataset based on the pre-trained model. Next, let's see how to annotate the dataset for the YOLOv8 model. YOLOv8 has a simple annotation format, which is the same as the YOLOv5 PyTorch TXT annotation format, which is a modified version of the darknet annotation format. Every image sample has one TXT file with one line for each bounding box, and the format of each row is presented here. So first we have the class ID, and we have the center X and Y coordinates, and we have the width and height. Notice that each field is space delimited and the coordinates are normalized from 0 to 1. You can see that the coordinates are between 0 and 1. Once we annotate the dataset, we can organize the images and partition them into the training, testing, and valid sets. The data.yaml file contains information used by the model to locate images and map class names to the class IDs. This is similar to the YOLOv5, so if you have already implemented the YOLOv5 model before, it's similar, so you can just go and modify the data.yaml file according to your custom dataset. By default, it will have 80 classes, and you're going to have to change it depending on your task. So for example, if you have 5 classes, you can change the number of classes and the names for each class. So how do we annotate the dataset? So previously we have to manually label each image by ourselves using the Label Me GitHub repo or other platforms, but now they have made the labeling process much easier by providing a website or platform which uses a pre-trained model in order to generate labels for your dataset. So another interesting application of the YOLOv8 is an object detector to speed up your labeling workflow. In the same way ChatGPT has sped up the time it takes to write emails or code, YOLOv8 is perfect to implement as a backbone for AI-assisted labeling. So InCord Annotate is the name of the platform, which supports a novel approach based on micromodels, which are purposefully overfitted models trained on just a few labels for targeted use cases. So first, you can upload a couple of images on the website, and it's going to overfit a model or train a model behind the scenes. Then it's going to generate prediction bounding boxes for the next set of images that you upload to the platform once it's already familiar with the objects you want to annotate. Then once you generate just the few labels that you want for your custom dataset, then you can just use the platform to generate the rest of the labels. So this might be useful when you have a lot of images, for example, thousands of images, and you don't have the time to annotate or label all of the images by hand manually. This can be helpful because it generates the coordinates by itself for each ground truth bounding boxes, and using the format used for training a YOLO V8 model. How does YOLO V8 compare to previous models? The Ultralytics team has once again benchmarked YOLO V8 against the COCO dataset and achieved impressive results compared to previous YOLO versions across all 5 model sizes. Here on the image, you can see that each model is depicted by using different colors, and the blue line on the top shows the YOLO V8 model. Whenever you want to compare the performance of different state-of-the-art models, you have to use 3 metrics. The first one is measuring the performance using the metric mean average precision. Second is the speed of inference, which is in frames per second. Third, you need to show the computation cost, the size of the model in flops and params. Here you can see the YOLO V8 model outperforms all of the previous models. The yellow line indicates, the orange line indicates YOLO V7, the green line YOLO V6, and the red line YOLO V5. And you can also see that on the x-axis, the number of parameters are actually lower than the previous models. And on the y-axis, we can see that the mean average precision is higher. So it has less parameters and higher mean average precision, which is what we want. And here on the right side, we can see the speed in terms of frames per second. For the object detection comparison of the 5 model sizes, the YOLO V8 medium version achieved a mean average precision of 50.2% on the COCO dataset, whereas the largest model, which is the extra large version, achieved a 53.9% mean average precision, more than double the number of parameters. So when you see the number of parameters, it's increasing when we go from the smallest model to the largest model. And here you can see that this is the speed, and on CPU and on TensorRT, and here you have the mean average precision. All of them are using the same image size so that it is a fair comparison. And you can see that the number of parameters has almost doubled from here to here, but the accuracy is higher. Finally, let's conclude by comparing the YOLO V5 and YOLO V8 model. YOLO V8 is the state-of-the-art. Although YOLO V5 was fast, easy, and accurate, it never was the best in the world at what it did. YOLO V8 changes this. It is faster and more accurate than all the other models available. It is even simpler. With YOLO V5, it was necessary to clone the repo and set up your environment manually. While this is still an option for those who enjoy getting their hands dirty, setting up the environments by yourself. To get started with YOLO V8, you can just install the repo as a pip package. You can just call pip install Ultralytics and you can access the YOLO V8 model. YOLO V8 becomes a platform. Instead of just being previously a GitHub repo, now it's a platform. Migrating away from a single architecture, YOLO V8 supports every single YOLO version, including those of their competitors. They also promised that YOLO V8 will have a paper, and a point of contention with YOLO V5 was always a lack of scientific paper. With YOLO V8, expect a paper to be published in the coming weeks. YOLO V8 will be heavily maintained, prioritizing immediate inclusion. YOLO V8 will always stay up to date with the latest advances in the vision AI space, and it caters to a wide range of object detection and segmentation tasks. Due to its extensibility, it takes on a number of innovations, including a new backbone network, anchor-free detection head, and loss function. It is also more efficient and it can be run on a variety of hardware platforms from CPUs to GPUs. That's all about the YOLO V8 model. If you have any questions about what we have discussed in this video, you can leave your questions on the comment section. You can follow us on our YouTube channel, and also I will be uploading some materials and resources on the websites which are not included from the YouTube channel. Thank you for watching this video, and I hope you learned something new.
Audio Jungle.